Hi everyone, I'm Vincenzo Paparella from Politecnico di Bari, and here I present our work, Reproducibility of Multi-Objective Reinforcement Learning Recommendation, Interplay between Effectiveness and Beyond Accuracy Perspectives, with Vito Walter Anelli and Tommaso Di Noia from Politecnico di Bari, and Ludovico Boratto from University of Cagliari. This is the outline of our presentation, and we start by motivating this work. Currently, the main efforts of RecSys community are devoted to construct algorithms that can propose accurate and relevant items to users. But we all know that many other factors are crucial for the final recommendation. For instance, the diversity and novelty of recommendations for sparking the user interest, or the fairness to accomplish the recent regulations of trustworthy artificial intelligence. And in this regard, multi-objective recommender systems meet all these requirements since they are built to consider simultaneously multiple objectives through a process of multi-objective optimization. Another important factor for the RecSys community is the reproducibility of the works, mainly since it is a crucial criterion for the peer reviewing process. Examining the works regarding multi-objective recommendation, we find out that few works are considered reproducible, since few works are combined with their source codes and datasets. So, after conducting this brief survey of the context of reproducibility in multi-objective recommender systems, we go deep into this, and we reproduce the work by Stamenkovic and co-authors with their source codes and datasets. We decided to reproduce this work since it focuses only on user-centered metrics, and this paves the way to extend the evaluation of the proposed framework. And in addition, we assess if their framework allows to control the influence of each objective separately. So now I briefly present the approach we are reproducing. The authors develop the scalarized multi-objective reinforcement learning agent to simultaneously pursue the accuracy, the diversity, and the novelty of recommendation in session-based recommendation. So they formulate the next item recommendation problem as a multi-objective Markov decision process, which in contrast to a classic Markov decision process, it is characterized by a vector of rewards. Indeed, when the authors aim to find the target policy to maximize the expected cumulative reward, they exploit a linear scalarization function where they assign to each objective a weight. Through these weights, they assign an importance to each objective. Specifically, they assign the same importance to the accuracy, the diversity, and the novelty of recommendation by setting these weights equal to 1. This is the definition of the rewards in the considered framework, and finally, the loss function is divided in two parts. The first one from the self-supervised head, which is a cross-entropy loss function, and the second one from the scalarized multi-objective reinforcement learning part, where they exploit the SDQL algorithm. Now we start with our experiments. And in this first part, we want to assess if the results from the original paper are replicable, and then consider the weight settings described before. We want to analyze if this framework allows to control these objectives separately. For this reason, we employ the same experimental settings of the original paper, but it is worth mentioning that we choose the best iteration of the training process according to the value of NDCG on the validation set. And we say this because the authors did not provide any information about that, even if we are dealing with the multiple objectives and we are giving the same importance to the objectives. These are the results for what regard the reproducibility, and we report both the results from the original paper and our results, and we observe that we can consistently replicate the trends of small from the accuracy side, but such trends are not as equal as in the original paper from the beyond accuracy sides. And we conjecture that these observed differences are due to the selection strategy adopted to report the results in the paper, and so to select the best model. Indeed, since we are dealing with multiple objectives, it is not clear how to choose the best model, and this opens perspective issues in MORS. And in this regard, I will present a full paper in the next CIKM. Now we move to the second research question. In this table, we can observe the weight settings we explored. So when a weight is equal to 1, this means that we are considering the reinforcing of that objective. Otherwise, it is 0. We observe that when we reinforce the accuracy of recommendation, effectively we can control, we observe an improvement of the performance on this regard. While when we are more difficulties when controlling diversity and novelty individually due to their positive correlation. So the take-home message here is that we can train recommender systems to pursue simultaneously multiple objectives, but the risk is that we probably cannot have the control over them. And this opens a cast in MORS on how many objectives to consider in a system and if it is counterproductive to their control to consider more than 2 or 3 objectives. Now we extend the evaluation of this framework to the algorithmic bias. Firstly, we want to assess if small is responsible for bias disparity for certain categories of items, given the bias in the source. And then we want to evaluate the items' exposures in terms of their popularity from the equality and equity point of view. To do so, since most of algorithmic bias metrics are not suitable for the next item recommendation task, we must cast this task into a classical one. And to do so, we consider only the last recommendation list provided at the last timestamp, and we treat sessions as users. We exploit the Elliott recommendation framework to compute the bias disparity, where we consider the categories of item from some properties provided within the dataset, and then we compute the RSP and RIO metrics for what regards the item's popularity. Okay, these are the results for the bias disparity. In the top of the table, we have the categories of the items. We have the bias in the source and in the output separated by a slash, and between parentheses, we have the bias disparity. We notice that the third category of items is characterized by a strong positive bias, since the value is much greater than 1. This means that these items are consumed by the users disproportionately with respect to the category size. So this means that these items are mainstream items. We observe that the small approach with respect to the vanilla baselines reduces the bias in the output, but of course this injects a bias disparity. Conversely, the category of items number 10 is characterized by a negative source bias, since the value is much less than 1, and this means that the items in this category are highly niche items. And we observe that the small approach reduces the exposure of these items, resulting in an unfair situation from the provider side. We assign the responsibility of these results to the reinforcing mechanism. Indeed, since we are reinforcing the accuracy, in this way we can potentially reduce the exposure of highly niche items, as seen for the category number 10, but reinforcing diversity and novelty objectives decreases the bias of categories containing many interacted items. So here the take-home message is that despite focusing on user-centered objectives, we should be aware of what is happening on the other sides of recommendation. Finally, for what regard the last research question, we do not observe particular trends for what regards the items exposure in terms of equality, but we observe that small tend to worsen the recommendation bias in terms of popularity from the equity side, since the pop-rio values are in general higher when we integrate the baselines with small with respect to the vanilla baselines. So in conclusion, we, after briefly surveying the state of the art of Morse works, mainly from the reproducibility point of view, we replicate the work by Stamenkovic and colleagues, and our experiments led to some observation that we summarize as follows. We open some perspective issues in Morse regarding the selection of the best models, since we are dealing with multiple objectives. We open some cases about the control of the objectives we are considering during the recommendation training. And finally, we remember that the recommendations are multi-sided, so even if we are considering only user-centered objectives, we should be aware of what is happening on the other coins of the recommendations. Thank you.
Thank you. Until we get more questions, one thing that I would like to know, what do you think that us, as readers of the paper, should take as key takeaways of this paper? What's the message that you would like to convey, whether it's to promote papers that deals with reproducibility or to highlight the importance of making more reproducible papers? So,
okay, my main research topic is multi-objective recommender systems. So I'd like to pass this message that multi-objective recommender systems are, for certain points of view, different from classic collaborative filtering approach. Even for some simple actions like the selections of the best models to show the results in the papers, since we are dealing with multiple objectives, for example. Indeed, we know that common practices in RecSys community for classic recommendation models that considers only accuracy is to select a model according to an accuracy metric. And we show that this can jeopardize the reproducibility of multi-objective recommender systems, and at least we should define a unique strategy to do that and to write it on the paper.
I see, thank you. So we got time for last question. The question is, do you see any way to make multi-objective recommender system controllable with respect to individual objectives? What needs to be done in order to achieve that?
I think that a preliminary analysis of the objectives we are considering is needed. So if we observe that the objectives are positively correlated, maybe we should consider only one during the training phase and not both of them, as seen in this work. In my opinion, how many objectives to consider is the true questions and the more challenging.
Thank you so much. So let's thank the speaker again.